Hello, we're going to talk about the topic of addressing fraction, addition, and subtraction errors. I chose this topic because I honestly did not truly understand fractions until I took Dr. Strawhecker's math class while I was getting my Bachelor of Arts degree in teaching when I was 22 years old. I found it utterly fascinating that fractions actually had meaning and could be understood and worked through instead of simply being looked at with procedural drill and kill, like invert and multiply, take the denominator times the whole number and add the numerator, and all those fun different things that teachers throw at students that are just procedural. I literally never ever looked at fractions visually or conceptually until I was in college and 22 years old. So the reason why I wanted this topic is so that I could avoid other people having to go through that same experience. I want to teach kids to be able to understand fractions and know that they are parts of a whole and let them conceptually understand them so they're not just spitting back different methods that a teacher has drilled into their brains. When I was younger, if you gave me a story problem that had anything to do with fractions, I could rarely ever answer it correctly because I had no base knowledge and conceptual knowledge of what a fraction was. I always want to learn as much as I can now about fractions so that when students come to me or my own children come to me with questions about fractions, I can break it down conceptually to answer the questions for them. Could never answer students' questions about fractions well or in a conceptual way because I myself didn't know what the fractions we're talking about. And that's why I chose this meme here. It has this teacher saying 5/3 of the class don't understand a word I'm saying about fractions. And I feel like it was me. I was a hypocritical teacher and student for that matter when I was trying to explain fractions to kids and I myself didn't understand them well. And I'm still learning. I am the first to admit that I am still learning about fractions and how to break things apart. And even in this class, I look at how the students worked with fractions in videos and how the students in this article that I read worked with fractions. And I'm just in awe of them. I'm jealous of them because they have such a better understanding at age 10 than honestly I believe I still do at age 35. So I wanted to continue to learn and build my knowledge in fractions so I can help my own children and students in the future. In my professional article, I found 4 key points. Mac had a purpose and intention before beginning her lessons. So I feel like that is the most important thing that teachers forget a lot of the time. We go into teaching any type of subject and we don't have what outcome we want in the end. She had a purpose and intention for what the students were going to know and what she wanted them to know by the end of this lesson with adding and subtracting fractions. She had the big idea that she wanted the students to end up knowing that not only are the numbers pieces of a whole, but also the fractional sizes of the pieces involved. She wanted to know that they knew what sizes of each of the individual pieces were and how to use those manipulatives to represent fractions. I think it's crucial that students have a basis for understanding fractions before the addition and subtraction part of the fractions come in. They have to have a strong fundamental conceptual understanding of fractions first so they can successfully add and subtract fractions. They have to understand and be able to describe why they are doing what they are doing. The next part was that what I thought was absolutely phenomenal in the article is that she was beginning to teach children adding and subtracting fractions. And she didn't give them just a number sentence like 1/3 plus 1/3 equals blank, or 2/4 plus 1/4 equals blank. Anytime in my history and background of teaching, number sentences is where you started. Story problems have just been an end result thing or a higher level thinking problem to give to students. She began her learning with story problems. And so I thought that was fantastic. She began her first story problem like, you have 3/8 of a medium pepperoni pizza. I give you 2/8 more of a medium pepperoni pizza. How much of a medium pepperoni pizza do you have now? So instead of starting the students with just a basic number sentence, she came right out of the gate right away and started with a story problem where the students had to dive into it and talk through it. That leads me into the next bullet that I found fascinating about the article, and that the students led the conversations and thinking in the study. When Nancy Mack was doing her study in her article, she let them proceed with their thinking. She did a masterful job of asking questions like, how do you know that? And giving them suggested answers like, well, what if I think the answer is 5/16? Where she would present a misconception in a question. For example, the pizzas where I have 2/8 plus 3/8, the student showed it with manipulatives and said, I have 5/8. She went on to say, well, what if I said, I think the answer is 5/16? Whereas she presented the misconception of adding the denominators in a question. Then the student had to walk through the problem showing with manipulatives that doesn't even make sense. The misconception doesn't make sense because you were working with pieces with eighths pieces, and he could show that visually to her. And then finally, the student thinking led the progression. Honestly, for me, that was the biggest aha moment during this article. She didn't follow the textbook or what a textbook traditionally shows as being the right way to present fractions. She let the kids thinking progress how they were going to, what next step they were going to take. For example, usually a textbook says I'm going to work on adding fractions with like denominators, then I'm going to add fractions with unlike denominators. That's not what she took. She saw that the students were doing well with adding like denominators, but then they wanted to talk about taking away from a whole. So she put in their wholes taking away a fraction. This wasn't what the textbook suggested to do, but the student thinking led it that way, so she continued to go with what the students' progression and their thinking sequence brought out of them. She wanted the students to take ownership in the next problem they were working on. I'm going to build on what I was saying from the previous slide. Here's some examples of, in the article, what Mack was suggesting with story problems, and then how students' solutions were differing and how they had their own thought processes on it. So she would give them a story problem such as this. You have a board that is 3 yards long. You cut off a piece that is 5/6 of a yard long to make a shelf for your room. How much of the board do you have left? So one student's thinking was that they had 3 wholes minus 5/6, and you could see here that they had a good enough conceptual understanding of fractions that they knew that a whole, and we're working with 6, had to be in sixths. So they did 6, 12, 18. They subtracted the 18/6 minus the 5/6, and then in the article they even went on to find out how to rename improper fractions to mixed numbers on their own because of their good conceptual understanding of fractions. This is by far, this is just a little list that I came up with myself. In the article, this is how the student progression was. They started by adding and subtracting like denominators. Then they moved to adding like denominators to get a mixed number. You can see how they progressed. Now, in a typical progression that I've seen in a textbook and how I remember learning it myself as a student is this way. Notice here that adding like denominators to get a mixed number was the second step in the student progression in the article, and then it was the third here. This is the big one for me. Subtracting a fraction from a whole number was the third step in student thinking. That didn't come down till clear step number 6 in a typical textbook progression. And then here, subtracting a fraction from a mixed number, that's the fourth step in the student thinking, and it's the seventh step in a textbook. It's like we aren't following what students, how they learn. Right here is a big one too. Students weren't ready to learn how to add and subtract from unlike denominators clear until the 6th step. In regular textbooks, we introduce that right away on the 2nd step. And so students' brains aren't in that thinking sequence yet, and so they get confused, especially students with learning disabilities or anything like that. We're mixing up the step sequence and how their brains are processing the information, and that is just the biggest discovery that I found in this article. The article to textbook connection. When I was reading the article, the article and the text recognize the common misconceptions and errors as being the same. They both recognize that students usually have a problem adding both the numerators and the denominators, and then the different things like identifying common denominators and finding common multiples. That was the same, I believe, from the article to our textbook. However, I did find that there were some things that were the same on how to help the students overcome these misconceptions, but I found that there were differences too. So, for example, in the textbook, it talks about using models, of course, to show students a visual representation of what fractions looks like. And honestly, they used pizza, and I think that's one of the most common things used. But something that I found that was different is that here it says the misconception is finding difficulties with common multiples. And the text suggested to work on having students list a series of multiples for each denominator and then have them stop when they reach the same number. This is super procedural. And being a former special education teacher, I can tell you that that's not going to be a good option for students that struggle with that kind of thing. In the article, she has it more with visuals and modeling. And having students find out what part of the model is going to visually represent and tie into and make an equivalent fraction using the modeling strategy of manipulatives. So that's where that was different there. The book was more procedural. The article was way more hands-on and manipulative. The failing to estimate, let's focus on that a little bit. In this article, the students that were used in this article definitely had a good basis of what fractions meant from the get-go. If kids don't know what the fractions mean and can estimate a good answer, then they're not going to be able to understand that the answer they get when they add and subtract is right or wrong, because they can't estimate what it should be. So the misconceptions and errors were the same in the text as they were in the book, but then the ways of how to help, the book tended to be way more procedural, where the article was more manipulative and hands-on. When connecting Nancy Mack's study to the dimensions of a productive classroom, I wanted to hone in on two specific